In this lesson, we'll cover the essentials of channel packing, focusing on ORM, metallic with smoothness, as well as DirectX and OpenGL normal maps. We'll use Blender to convert standard PBR textures into these formats, helping you optimize your textures for different 3D applications. Here we have our old trusty hammer with all the textures I exported from Substance Painter. For now, the material works for Blender and it's pretty much a standard to have these PBR textures, but sometimes, like in Unreal Engine, we might need to provide the textures a little bit differently. ORM stands for Occlusion Roughness Metallic, and it is a way of packing 3 textures into a single file, which can improve rendering efficiency, and we also reduce the number of texture files needed. It might sound complicated, and to be honest, if you would use Photoshop or other 2D program to do it, switching between different files, copying and pasting individual channels and making it work is, well, let's say time-consuming. But fortunately, in Blender, it's easy. I made a scene with already prepared nodes. I added a combined color node to see how the image is going to look like. The ambient occlusion map is plugged into the red channel, the roughness to the green channel, and metallic to the blue channel. We can see the combined textures and they look funny, a bit like a toxic candy hammer. The look of this texture depends on these 3 maps we put into RGB channel, so if you're using another model, it might look different. Now let's actually pack it. We need to use Compositor. We haven't used it in this course, but it's not difficult to use it, so let's select the Compositing tab. We need to check this little checkbox at the top to use nodes, and we can see Render Layers node now. But now we want to mix textures, so we will delete it. Instead of the Render Layers node, we'll use 3 image textures, so let's add 3 image nodes in Shift-A, Input, Image. I will just duplicate this one 2 times. Now let's find ambient occlusion in the first one, roughness in the second, and metallic in the third. We can see that they have this little preview above them, so we can make sure it's exactly what we want. Now we need to add a combined color node from Shift-A, Color, Mix, Combine Color, and plug ambient occlusion to the red channel, roughness to the green channel, and metallic to the blue channel. If we press Ctrl-Shift on the combined color, you can see the same colors as in the viewport some time ago, so it's definitely working. We can also zoom it out a bit with pressing V. Now we just need to save the texture. For this, I will make sure I have my combined color plugged into the color input of the composite node, and we will render the texture. The thing we need to remember about is to set the dimensions of the render to be exactly the same as our texture size, so for this case it will be 2048 by 2048. Let's press F12 to render, and after a second we have the ORM texture. We can save it as a typical texture, and now you can use it in Unreal or other software. Next thing we'll be packing is a metallic smoothness map used in Unity. This engine uses smoothness, which is the inverted roughness. Both textures, metallic and smoothness, are packed into one, but this time smoothness is packed to the alpha of the metallic map. I will close the window with rendered ORM texture, go to the Shading tab, and switch collection to Smoothness Workflow. I prepared the invert node just to show you how it looks like. So as you probably thought, everything what was glossy is now rough, and everything that was rough is now glossy. And after this amazing presentation, we can go back to the Compositing tab. We don't have separate Compositing tabs for different collections, so I will use the nodes we already added, and I will unplug the viewer because those colors are really crazy. Ctrl right click to cut the link, and I will also disconnect roughness and ambient occlusion. To be super precise, we should add a separate color node and then connect each color with the corresponding channel in the combine color. But we can also plug the metallic image output to all three channels in the combine color node, and it will work exactly the same. And as you probably guessed it, we need to invert the roughness, so we'll add invert color node from Shift A, color, invert color, plug roughness to it, and then plug the color of the invert color node to the alpha of combine color node. If we press Ctrl Shift on the combine color now, we'll see that it is white and gray, but let's select a color channel to display above, next to the backdrop button, and we see that it is our metallic texture. Next to it, we have alpha, and we see inverted roughness map. So everything is where it should be. I will switch back to the color and alpha preview. And again, we need to set the resolution, but we already changed it for the ORM texture, so let's just press F12, and immediately we have the rendered texture. Be sure that when saving it, for example to PNG, you have RGBA color option selected. And now it will work perfectly in Unity. The third example will be the normal map format. Blender, as well as Unity, Cinema 4D, and many more supports OpenGL normal maps. Unreal, 3ds Max, or CryEngine use DirectX normal maps. The main difference between these two types is the green channel. DirectX expects the first pixel to be at the top, while OpenGL expects it to be at the bottom, and white channel is responsible for this top-bottom direction. That's why we need to switch it. Let's go back to the Shading tab and select the OpenGL DirectX Normals collection. I will press Ctrl Shift on the default normal map, and then on the combine color after inverting the green channel. There is a slight difference. The DirectX map in Blender might appear inverted, so everything what was concave is now convex. Let's go back to the compositor, disconnect all the nodes, and add another image. This time it will be normal. I will just duplicate existing one and find the normal map. We already have the combine color node, so we need the separate color node. We will find it in Shift A, Color, Mix, Separate Color. Now let's plug the normal image output to the image input of the separate color node, link red to red in the combine color, as well as blue to the blue in the combine color. And now we'll take the green channel and plug it into the invert color node we already have here, and plug this inverted color to the green channel. Now if we press Ctrl Shift on the original texture, and then on the combine color node, we see the same what we saw in the viewport. And the rest is the same as with the previous textures we rendered. Let's just press F12, and we rendered a DirectX normal map. So as you can see, you can use the compositor to easily pack textures into channels, and if you will ever need any of these textures, you know how to make them now.